Okay, we can start. It was a horrible rain with severe wind. In front of me only 3-4 trees fell here and very murderous lightning. But power came now. Even UPS also you can't use because danger. Now, everything clear? Voice fully clear? We will start. I am using full board, so little gap will be there. Let it be there, no problem. Because full board I require. Okay, start. See, now, remember, anybody who joined new today, first of all, if anybody joined new today, he or she should go to yesterday's class, study and come back. Not suddenly ask, what is going on? Okay, continue. I will read the question once again. A beam of length 8 meter is subjected to two downward point loads of 2200 and 2800 kilonewton at 1.4 meter from left end and 1.6 meter from right end. So this will become 5 meter. Why? Total 8. Also, clockwise couple of 250 at the left side load point, anti-clockwise couple of 300 at the right side load point. And this beam is subjected to upward load in the form of UVL represented by a trapezium whose intensity from left end, I don't remember, some kilonewton per meter, left end some kilonewton per meter to right end some other kilonewton per meter. I had given yesterday what is this value and what is this value. No place to write. Why should I write it? Refer yesterday's class. I have given. I don't remember what was the intensity. Okay, now. And the one who gave the question, he guaranteed that this complete force system is in equilibrium. Yes, that you checked last time. Now, without bothering about what is this beam, start SFD&BMD. And I told you, this is very powerful example for design of combined footing. So that all I told yesterday. Later in the respective RCC class or ETAP class, I will tell more about this one. Here we are interested only in SFD&BMD. Now see, so you want, see, A, B, C, D, or you can tell one thing. If you invert it, it will become simply supported beam with double overhang with downward what? Uniformly varying load and two couples. Then these two will become upward reaction. But now for the given beam, you draw SFD&BMD. See, I will project everything here. Sorry. This blue color is meant only for that one. I will tell you later. Blue color important. Light line project. When red is not required, you get the red color. When I want the red color, it won't come. I will search for it. Okay, start. Come this way. Available space I will draw. What you do is, you take a big drawing sheet. Use depth-wise. Write very, very neatly. As neat as possible. Okay, start. Now we are entering SFD&BMD for this beam. Nobody can question how this value came, how that came, all I told. It is a given question for everybody now. General public for interested in SFD&BMD, given data. Some will ask, where is support reaction? I told you there, and I will tell in the ETAB and SAFE class and RCC class. Light line, project the points. Very light line. Now see. See now, I will draw baseline later for SFD&BMD. Okay. Little later I will draw. See, this is the baseline for SFD. Sufficient space. I think I will manage because why? I want more space for BMD. This is shearing force diagram. All values are in kilonewton. Left up, right down, positive. I should not tell these things again and again. How many times told, I don't know. Okay, stop. You need shear force for SFD. You need shearing force at all the standard point at C, at A, at B, and at D. These all you have to write. See, first shearing force diagram. What all I tell those who are serious should write for shear force diagram. Okay, shear force calculations. Again I will write left up, right down, positive. Okay. Now you need shear force at C, shear force at A, shear force at B, and shear force at D. And also make a note. I won't tell today. Today I will not tell. How many times I have to tell? At A and B, see, you make a note. I will remove it now. At A and B, later I will not write. There are powers. Therefore, at A and B, shear force calculation, tell the answer. Shear force calculation, how many times? At A and B, shear force calculation. No, answer not required. Why should I give? If somebody is absent for yesterday's class, let them keep on wondering, what is this one? Or they will realize, oh, I should see the previous class and come back here. It is their responsibility. So, anyway, I don't require that values. Why means I told yesterday. Shear force you have to do twice. Once just to left and then just to right. At this point, once just to left, then just to right. Once just to left, then just to right. Over. Stop. Now, see, when you want shear force anywhere, you look this side. You have to consider the downward. If you are here, only this UVL. If you are here, you have to consider the downward load and upward load. If you are here, you have to consider that load, this load, and upward load. It will be laborious. So what? It will be very time consuming. So what we have done is, anywhere from here, see, I told you very clearly, X from where? I told you, section XX I have taken. Tell me, X from where? Very important. Now I want red color, not getting it. See, now I want red color. I got it. Very important. X from, tell where X you have taken. X from left extreme and C. See, from here we are taking distance X. Red color I will use. X I will take red color this way. Wherever you want. See, what you have done is, do not see the upward load and couple. See only that blue color loading. Blue color is upward load due to uniformly varying. Actually, upward load due to pressure below the footing slab. Okay, leave it. Now, if I want shear force here, I want this much load. If I want shear force here, I want this much load. Other loads are there. If I want shear force here, I want this much load. One side. Shear force we are doing from left side. I told you. From one side you will do. Now, up to here or up to here or up to here means you need this intensity. You need this intensity. Then you have to struggle. To avoid that problem, what you have done? Anywhere at X from here. See, I told you. At any point. See, yesterday I have given a sketch for you. If you remember. See, yesterday I have given a sketch for you also. See, the blue color one. Right time I won't get blue color. The other one. Same. It is the same trouble. Okay. See, pressure diagram is like this. This is the pressure diagram. Upward load. This point is C. This point is D. Do not see A and B. Nobody wants it. Do not see A and D. Only experiments. Take a section here at X from here up to a section XX at X from here. If you want shear force here only for this load, see, look this side. It is left up, positive. So the shear force is how much? It is total load from here up to there. That we wrote yesterday. This much load is here. So if I write this V dash X, it will account for shearing force at any section XX, looking left side, any section XX, but it will give shear force only due to upward UVL. That is only due to blue color load. Outside black load and couple, you have to account separately. And suppose I want bending moment here. It is moment of this load about this point. See, sagging, positive. So it is positive. We got it, positive. Now, that one, again you have struggle. Somewhere here, this intensity, or at X from here, anywhere between C and D, if you have bending moment, it is moment of this load about this point, sagging positive. That is equation here. So use this one for shear force, use this one for bending moment only due to upward UVL wherever you want. By substituting suitable value of X, X is measured from left extreme end. Tell me, this much clear? Fast. This much clear? If not clear, and if you don't see yesterday's class, whether you understand or not, I hardly bother. Clear? See, I should be very harsh. People suddenly coming will tell full confusion, nothing clear. I will tell leave, go away from my class. Dedication is not there means you cannot understand properly in my class. Okay, start. Now, first here, first point I will take a piece C. C. This color is not writing. I will use some other color, not other color. Okay. First point is C. Okay, C. Start. Shear force at C equal to, look this side, there is nothing there. And even here also, when you put X equal to 0, nothing is there, 0. So shear force here is 0, over, down. After C, come to A. Just now I told you, at A, point load is there, shear force, twice you have to calculate. Start. This you write here. Shear force at A in the bracket just to left of A. Just to left of A means, see, somewhere here. Slightly this side. Look this side. When you look this side, you cannot see any downward load. You can see only upward UVL from C up to A. From C up to A, whatever upward UVL is there, that shear force is V dash X equal to plus V dash X. X I should use red color to understand. I am giving so much effort I am putting. Plus V dash X. Red is permanently required now. I will separate the red color with the red cap only. Okay. Let it be in the pocket. And blue also required. 1 minute. For a complete understanding, colors are important today. Yes, this is black. 1 minute. I get the blue. This is blue. I will put a blue color only. Otherwise confusion. That is color confusion. Okay. Okay. Now I will be careful. Red and blue are in the pocket. Okay. No. Plus V dash X. That's all. Plus V dash X equal to, in the bracket, tell me, substitute X equal to how much? See, so fast. Color got mixed up there. Okay, okay. That is a habit, what to do. I'll put black there. In the bracket, right, substitute x equal to, how much, tell me first. Substitute x equal to, answer. X equal to 1.4 meter. Start. Substitute yourself and tell the answer. Substitute. You write it. There is no place to write. Why should I write? If you are interested in solving, you will write. If you are not interested, what I can do? So those who are serious should write equal to 535.9375 into 1.4 plus 11.1328125 into 1.4 square. Give me third decimal accuracy. Answer. Third decimal sufficient. 772.1328 plus 772.133 kilonewton, and shear force at A in the bracket just to what? Right of A means, see, come slightly this side. Here, look once again this side. So, whatever shear force you got there, plus 772.133 minus 2200. If not clear, then you are wasting your time coming to my class. After today's 118 class in SFD&BMD, this has been told endless number of times. Answer. Answer. This has told endless number of times. Answer. Why no answer? Minus 1427 minus 1427 point. No, not 87. It is 867. Give third decimal. Give third decimal. Actually, second decimal is sufficient. Okay, why you waste time? Write second decimal sufficient. Why? It is a design problem. For design problem, who will go for more than second decimal? So it is 87. Okay, over. That will clear the point A. Now, come to point B. Come to point B. Start. Once again write. At B also, there is a point load, shear force twice. So, shear force at B just to left of B equal to, see now, what you have done earlier, like what? Copy the previous value. That you cannot do now. Tell why. If you copy the previous value, you will get the shear force here, just to right side here. There, this much UVL is already accounted. Now, if you use this equation, it will give value of shear force for right from here. Clear now? What you used to do earlier. See, what we used to do earlier, like what? Previous value minus total load, what minus actually, plus y upward load. Previous value, then plus whatever load from here to here. Then problem, because there is no expression for load from here to here. Therefore, what to do, tell me? So therefore, once again, clear now? If I use the previous value, I want further changes from here to here. Here to here, expression is not there. That expression will give you shear force for load right from C up to there. Therefore, start once again. It is once again what? It is once again, clear this point? Once again, plus V dash x. V dash x, tell me, in the bracket, substitute x equal to how much? X equal to, up to here I want, plus V dash x, substitute x equal to first. Substitute x equal to 6.4 meter. Why 6.4 meter? Because we want shear force here just to left means this full loading. Then minus, how much, tell me? When you want shear force here, minus how much? First, minus How much? Full you are doing. You are not cumulatively doing now. If you do cumulatively, you require part by part upper UVL. Full you do it. Minus 2200. Tell the answer first. Answer. In the equation for V dash x, put x equal to 6.4 meter. That is 535.937 into 6.4 plus 11.1328125 into 6.4 square plus 1686 plus 1686. What about changes? Give for second decimal. No. Give for second decimal. No. Why? You rounded number. Give for second decimal. The number only comes that much. Tell me. No decimals. See? Suddenly you skip the decimal means I get upset. You should give answer up to second decimal. Yes, okay. Thank you. Kilonewton. I forgot kilonewton here. Kilonewton. Then, and shear force at B just to right of B equal to just to right of B. Now see, you don't have start here. You know just to left. You want just to right. Whatever value you got, how much? Plus 1686 means what? All these loads minus 2800. Answer. Minus 2800 will give shear force just to right. Minus 1114 kilonewton. Minus 1114 kilonewton. Over. Now, lastly, D. Actually waste of time. Why? Because at D, if you look right side, tell the shear force. If you look right side, tell the shear force. At D, if you look right side, shear force. If you look right side, see here what you do? What is the answer? You are plus V dash x. From here up to here, this load minus how much? Minus 2200, also minus 2800. Tell the answer. It has to come 0. Otherwise, class will close. Substitute fast. Substitute. I think you are not substituted, frankly. Anyway, substitute just for curiosity. Okay, leave it. Substitute later. Have confidence in me. It is 0. Over. Now, go back and draw shear force diagram. But remember, before that, what all I tell now, you should write. Because when you want to draw the diagram, you should do the variation. See, now, you write here, how is the shear force variation? C to A, UVL, A to B, again UVL, B to D, again UVL. Therefore, all these 3 points from C to A, then again from A to B, and again from B to D, shear force variation is what? Video is better. Why? No, it is clear. It is quite clear. No. I can see there. It is very, very clear. Okay. All, Arjan Madra, I am discussing about shear force. No, Arjan Madra, you hurried. Shear force variation. I am not telling bending moment variation. Shear force variation for uniformly varying load is not 3rd degree. See, it happens sometimes. In a hurry, it is parabolic variation of what degree? You just now wrote 3rd degree. No. See, earlier, in a hurry, you commented 3rd degree. No, it is parabolic variation, what degree? 2nd degree. Sometimes it happens. No, actually you are knowing it. Sometimes in a hurry it happens. That is bending moment later. 2nd degree. Start. Now, see. Or, see here. From here to here, you have to go up. you will reach here. Then you have to come down here. Again from here to here, you have to go up. It will come somewhere here. Then come down here and go up here. See the values now? Here. C to A, answer. 772. Highest upper side is 1686. Highest lower side is 1427. So I should be careful about scale. So I will write here how much? 772.13 available space. 772.13 here. And suddenly reduces to how much? 1427.87. Double of that one. Almost double. So space problem is there. I will reduce it and make double. See, 772.13 here negative 1427.87. And again upper side here, how much? 1686. Double of this one. Available space I will fully use here. Whatever space available, 1686. Then just to write is minus 1114, little lesser. Minus 1114, then 0. See, parabola second degree. Tell me, as you go, tell me intensity here is something. When you reach here, intensity increases. When intensity increases, today's class, next class I will do, next question I will do, when the intensity is this way. So today's example, from left to right, when you go, intensity increases. So slope should what? As you go this way, intensity increases. Therefore, slope should what? Slope should. Intensity increases. So slope should. Bega, fast. Today's example. Intensity increases. So slope of the shear force diagram should increase. And it is not zero slope here. Why? Slope is there. As you go here, slope has to increase. Tell me, is the curve this way or second way? First tell me. Is the curve first way or second way? First way or second way? As I go this way, slope should keep on increasing. See? Tell me, slope, it should become more and more steeper. First, it is first way. Now I will not waste time. Why? Because too much explained. But remember, not that way. From here to here. See, don't see there. It should go what? It should become what? It should become this. See, this way. So, see, even here slope is there. Slope here is this intensity. Slope here is this intensity, which is more. Then from here to here also, curve will be like this only. See? Smooth curve, 1 minute. 186. As you go here, again slope should increase. And this side slope is actually, this should be parallel to this line. Why? Either if I draw tangent here, slope is this intensity. So I will do one thing now. Okay, reasonably okay. Okay now, I will change later if requirement is there. Reasonably okay or not? 1.4, oh, it little smaller. It should have been little bigger, a 1.6. You go that side, you are disturbing me. Okay, 1 minute. 5 meter I will write here now, because space problem, 1 minute. At 5 meter, writing the distance is giving trouble. Okay, blue color better. 1 minute. I will manage it now. Once again. Unwanted, red is coming. This is 5 meter space problem. Manage martini. This is 5 meter here. This is 1.6 meter. 1.6 meter. Little 1427. ನೋಡಿ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇಲ್ಲಿ ಬರಬೇಕಾಗಿತ್ತು then okay. It is 1686. Therefore, from here, okay, reasonably okay. Later I will change it. Why? Because once I get this point, I will adjust the curve. Okay. Then come down here. Again what? As you go here, again slope should increase. Here, this slope equal to this slope. This slope is maximum. See. Okay. If I draw a tangent here and if I draw a tangent here, what will happen? Tell me. If I draw a tangent here or a tangent here, both, it does not look here. This tangent, see, ಸರಿಯಾಗಿ ಬರ್ತಾ ಇಲ್ಲ ಈ ಜಾಗ ಅವೈಲೇಬಲ್ ಸ್ಪೇಸ್ ಪ್ರಾಬ್ಲಮ್. It's a space problem only. As you go that way, slope should again increase. Finally here slope is the maximum slope. Okay, now reasonably okay. Don't bother. You should see, if I draw tangent here, you should merge here. See, this tangent should be parallel. So I should lightly flatten that one. Ayyo, in repair mada kashta agutte. If I repair further, okay, leave it now. Understood or not? Here space problem. Understood or not? I want understood or not. If somebody comments, let him comment. He does not know the difficulty of writing on the board with restricted space. I will tell him. I am telling in the class the principle, space problem, I could not manage. Then I will ask him. I will ask some questions to him. He will not answer. See, you don't know the basic concept and commenting on the slope, therefore don't do it. Over. Now, shear force diagram over. Now see, statement required. Shear force diagram over, statement required now. One, do not go to bending moment diagram. Once the shear force diagram is over, right, over. Once the shear force diagram is over, what you have to do? Immediately come back here. Observe the shear force diagram. Remember, this is point C, this is point A, this is point B, this is point D. Okay, this is point D. Observe the shearing force diagram. Tell me, is the shearing force diagram, does the shear force diagram cross the baseline at one place or two places or three places? Answer. You have to write all these what I am telling you should write. If you want to learn thoroughly what all I dictate here, you write. Tell me. Three places. Of the three places, are all the 3 points unknown? Tell me. Are all the 3 points unknown? Are all the 3 points unknown? Answer. Are all the 3 points unknown? Why? All those 3 points, are they unknown? No. Answer is no. I did not ask how many known. When I asked you, ಕನ್ನಡದಲ್ಲಿ ಅವರೆಲ್ಲರೂ ಮೂರು ಅಪರಿಚಿತರ, ಹಿಂದಿ not required, English, are all of them unknown points? No. Then 2 of them are known points, A and B. Therefore, keep quiet. There is only one unknown point, which is between which points? Only one unknown point, which is between which points? Which is between which points? There is only one unknown point, which is between A and B. Right here. One of them is unknown point between A and B. Say, I usually call the point E, because in RCC combined putting, I will later tell about the point E. I mark the same name there, E. But of course, new point E. So, I will come back here and mark the point E. Now, I want to locate it. To locate the point E, that is between A and B, where shear force equal to 0. Tell what to do. You write expression shear force at E equal to, tell the answer. You come here. Now distance required. Usually I take distance from nearest standard point. No, if I take x from here, then that equation you cannot use. If you are using that equation, tell me x should be from where? If I use this equation, x should be from, if I use this equation for shear force, x should be from C. Therefore, say, let C, that not C, let that point E be at what distance? At, see, x from, tell which point? Let that point E be at x from where? See right here. This is our x. X from where? Let that point E be at x from. Remember, this is an extra point. I will put a color for that one. Why? Important point. Color. Why? Important point. Okay. X from where? X from C. Let that point be at x from C. Now start. So this is our x. Now write shear force at E equal to, tell the answer, at x from here, shear force equal to whatever is shear force for upward load from here to here, that is nothing but this one only, equal to plus V dash x minus, how much, tell me, shear force here is whatever shear force due to upward UVL for x distance here, minus how much? Minus how much? Minus 2200. Equate that to 0. Why? Because at the point E, shear force equal to 0. Equate to 0. Now, therefore, 535.9375 into x plus 11.1328125 into x square minus 2200 is 0. See, there is a x here, there is one x here and one more x here. Okay, it came blue color. Okay, no problem. Okay, start. Therefore, tell the answer. Solve the quadratic equation. This will give a quadratic equation. Solve the quadratic equation. Tell me the value of x in meter. Two values will come. Give me both the values. Give me both the values, not one value. Give me both the values. One of them is 3.8043. 3.8043 meter, and tell me other value. This is positive. Other value. First, other value. Minus 51.9446. 9446. Now, our x point, our point E lies here at x from here. So, from C if you measure, your x will be 100%. See, it is 100% sure that your x value should be more than 1.4 meter and also less than, how much, tell me, measurement from here, your x is here, so that should be more than 1.4 but less than, how much? It should be more than 1.4 meter but less than 6.4 meter. Less than 6.4. Therefore, among these two values, you write applicable value. Therefore, applicable value of x. Remember, x from where? X from C is, tell the answer, 3.8043 meter. Fully clear? This is non-applicable. Clear or not? This is non-applicable. Clear or not? No, that I will tell in the BSK class only. Not, I told you, when I close YouTube class, when I start in Zoom app, when I continue our class in BSK, there I will tell you. Because I do not want such a sensitive matter to be known to public. Some will tell, sir, ಕನ್ನಡದಲ್ಲಿ ಜ್ಞಾನ ಹಂಚಿಕೊಳ್ಳಿ ಅಂತ ಹಂಚ್ತೀನಿ ಪರವಾಗಿಲ್ಲ, but there is a limit. I want that delicate matter to be told only for those who are my students. That's all. Who believe me and come to my classes. This is general public. So I told you, you remind me any day, any time I can tell. I don't have to prepare for it. When I am sleeping in the midnight, get me up and ask, yes, I can tell right then. I don't have to think about it. Any question in structures, I don't have to think. Okay, now 3.80 right here. Go back and enter. Go back and enter. Enter ಮಾಡಿ. Now do one thing. Some very important. See 1427 ಎಷ್ಟು x ಅಂದ್ರೆ ಎಷ್ಟು 3.8 1.4 ಅಂದ್ರೆ 1.4 another. Tell me how much from here to here? From 3.8043 subtract 1.4. What is the answer? From 3.8043 subtract 1.4. Answer. I will adjust it now. From 3.8043 subtract 1.4. 2.4 means from the midpoint of 5 meter, it is slightly which side? Tell me. From the midpoint of 5 meter, it is slightly to which side? Tell me. From the midpoint of 5 meter, it is slightly to which side? Where is slightly to? This is 5 meter. From midpoint of 5 meter, it is slightly to. Slightly left side. But here looks odd. I will tell you why. Nodi, shortage. This should have been little smaller. ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ತೀನಿ ನೋಡಿ, ನಾನು ಬರೆಸ್ತೀನಿ ಈಗ, ಗಾಬರಿ ಆಗಬೇಡಿ. ಇಲ್ಲಿ ಬರಬೇಕಾ? ಆಯ್ತು ನೋಡಿ. ಅಯ್ಯೋ ಈ ಕರುಗಳು ಬೇಜಾರು. ಓಕೆ, ನಾವು ಇಟ್ ಇಸ್ ಕಮಿಂಗ್ ರೀಸನೇಬಲ್. ಓಕೆ, ನಾವು ಸಿ ಇಟ್ ಇಸ್ ನಾಟ್ ಸ್ಟ್ರೈಟ್ ಲೈನ್, ಆ್ಯಕ್ಚುಲಿ ಇಟ್ ಇಸ್ ಅ ಪ್ಯಾರಾಬೋಲಿಕ್ ಲೈನ್. ಓಕೆ, ನಾವು correction. Why? I want some reason. No one should tell later. C is, this is E. Okay, now somewhat okay. So yes, now do one thing. See 87 1427 14 ಇದು ಮರ್ತೋಯ್ತು. ಅಯ್ಯೋ 1427.87 ಇರಬೇಕು. 729 729 ಕರೆಕ್ಟ್ ಬಿಡಿ 87. ಈಗ ನೋಡಿ, ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಇದು 772.13 7 ಆಯ್ತು. ಈಗ ನಾವು ರಿಮೆಂಬರ್, ನಾವು ಫ್ರಮ್ ಹಿಯರ್ ಟು ಹಿಯರ್ ಈಸ್ ವಾಟ್? ಯುವರ್ ಎಕ್ಸ್ ಯು ಟೋಲ್ಡ್ ಈಸ್ ಎಷ್ಟು? 3.8043 3.8043 right here now. This is your 3.ex value 8043 meter. Now remember, when I go to RCC class, I also want this distance. Tell the answer. In the RCC class, I want this distance because from the column up to what distance? What? Up to what distance? It is the point where your BM is maximum. Tell the answer now. RCC class, I want this distance. Tell the answer. It is 2.4043. No one can ask. 2.4043 meter. I will round off. That is from 3.8043 subtract 1.4. Also tell me AE, come this side. Okay. Tell me what is this distance. How to get it? From 5 subtract 2.4043. Here's the answer. Because RCC class, I require it. At that time in the RCC class, I will not explain anything. What I will do is, I will tell you how the upward UVL comes. Then I will tell. Now draw SFD&BMD. I will take my calculator. I will show my speed at that time. I will do. I will randomly do it at that time. Or I will adjust the class and tell, when you come to next class, prepare the diagram and send it in the WhatsApp group. I will not explain at that time. It to 2.5957. Remember, at that time I won't explain. I will tell, refer that class, critical class number 118, 117 and 118. 2.5957. 57 meter. Okay. I require it now. This red color is troubling me. Okay, now. Just a minute. Not a big one. Usual problem. All black. No, blue is here only. Okay. Blue is here only. Okay, now. SFD is complete. Some will comment. Sign akilla. Baba. Rental better. People are there. He wrote everything. He forgot to put a sign. I will tell them, you don't come to my class then. After explaining so much, if somebody comments, plus, minus, Kushi aita? Kushi aita. Okay, done. Okay, now start. SFD is completely over. Now go to, tell me, after SFD, now go to what? Now go to what? After SFD, go to. Today I want to finish this question. Go to BMD. For BMD. Okay, start. For BMD, sagging positive, BMD. Right, BM calculation. Sagging positive. Last time I will tell. When you want BM anywhere, you look only left side. Don't look right side, because if you look right side, you need moment of this side load. No, our formula is for this side. So, now, wherever you want BM, if you want BM due to upward load, answer is here. Answer is here. Substitute the value of X. I will stop this one now. Start. Standard point. First, BM at C. First point is C. Tell the answer. BM at C. Don't waste time. If you look this way, nothing is there. Or this upward load, put X equal to 0. Tell the answer. BM at C. How much? 0. Don't waste time. Over. Now, come to the point A. Make a note. You should make a note. I am not writing here. At A, there is a couple. When there is a couple, what I told, BM calculation should be twice. Once just to left side, then just to right side. 1000 times told. Start. Therefore, BM at A in the bracket just to left of A equal to, start, straight this side. Couple you cannot see. See, the couple is acting here. You are somewhere here now. So, look this side. If you look this side, you can see only BM due to upward load. That is nothing but what? That is nothing but your plus M dash X in the bracket X equal to, how much? Tell me. BM here is this much moment. It is plus of M dash X with X equal to, how much? X equal to 1.4 meter. Okay. Start. You substitute and tell the answer. Head. 267.96875 into 1.4 square plus 3.7109,375 into 1.4 cube. Second decimal is sufficient. Don't give wrong value. Plus 535.40 plus 535.40 kilonewton meter, and bending moment at A just to what? Right of A equal to, come just to right of A. You don't have to do anything. Just to left of A, how much you got? Plus 535.40. Then from just to left, when you come to just to right, tell me, is it plus 250 or minus 250? Do not see clockwise, anti-clockwise. It is, so many people still I am seeing telling clockwise positive. That is actually height of foolishness. Do not use clockwise, anti-clockwise. From just to left, if you come to just to right, tell me, is it plus 250 or minus 250? If not clear, go to my classes in SFD&BMD course. I don't remember class number, where so thoroughly I explained how to find BM, just to left, just right, including a crude method. Answer. It is including a crude method. See, this way, plus 250. Some newcomer will tell, not clear, no problem. Not clear means don't study from me. No, don't study from me. No, I won't study. I find, he will tell, no, I found your class good. Easy to understand. Then study everything. Then go back and start from class number 1. Suddenly in between, you can't understand. Answer. Plus S2. Plus 785.4. Plus 785.4 kilonewton meter. Okay. Now, after A, come to B. Some will tell, what about E? No. E is not a standard point. Somebody argued with me. Yes, E is a standard point. I don't want to tell whom. I told him, if E is a standard point, I will stop the teaching. He told, it is a point maximum BM. I agree. It is not a standard point because A to B single variation. At E, variation will not change. He told, yes, sorry. Suddenly he told, sorry. He told, I was under the impression that point is standard. Then he told me, now I fully agree with you. Yes. Then, if it is a standard point, A to E, E to B, different variation. No. A to B, it is an extra point. A to B is the standard point. Regular bus stop. This is a stop where traffic jam is there or some reason bus stopped there. Okay, start. B. Again right. At B also a couple is there. So, we want BM at B twice. Right here, twice. First, BM at B just to left of B equal to, see here, just to left of B means you are here. See, if the couple is not there, then only one BM. Clear now? Clear or not? If the couple is not there, only one BM. No confusion then. Okay, start. BM at B. But practical design, couple will be always there. You see E-tab and STAD model, when you right click on the diagram, you can see the sudden drop there. Okay, start. Here bending moment. Look this side. It is moment of this much load, upward load. That is nothing but your plus m dash x. Substitute x equal to how much? Tell me. When I want here, it is nothing but moment of load from here to here. Substitute x equal to how much? X equal to 6.4 meter, not over. Substitute x equal to 6.4, then minus 2200 into 5, then stand here, plus 250. Answer fast. Answer fast. In this equation, put x equal to 6.4 meter, then minus 2200 into 5 plus 250. 1198.8. Sulyadbaru plus 1198.8 kilonewton meter. And bending moment at B just to right of B. No, you can do one thing. Since you know bending moment just to left of B, from just to left, when you come to just to right, copy the same answer. Plus 1198.8. Tell me, from just to left, if you come to just to right, that couple will come. Is it plus 300 or minus 300? I will not explain. Is it plus 300 or minus 300? Minus 300. 350 alla, 300. Minus 300. Answer. See that you don't give any wrong value. See, because this class will be there in YouTube forever. Tomorrow I do not want someone comment values are wrong like that. But I can tell it is not done by me. But still take responsibility. Plus 898.8. Plus 898.8. 8 kilonewton meter over. Now, lastly, BM at D. Waste of time. Still do it. Look, come here. Look this side. It is moment of the entire upward UVL. That is once again plus M dash X. Substitute X equal to how much? Tell me. Plus M dash X. Substitute X equal to. X is from the left hand. How much? X equal to. It is plus M dash X. Substitute X equal to 8 meter. Not over. Then minus 2200 into 5 plus 1.6 is 6.6. Then plus 250, still not over. Minus 2800 into 1.6. Lastly, minus 300. You have confidence in me. Tell the answer. Without calculating, tell the answer. 0. My guarantee. 0. Over. Therefore, remember now, you write a note here. Bending moment at all the standard points are over. Still we are not ready for BMD. Tell why? Because we need also bending moment at the points where shear force is 0 or shear force diagram crosses baseline. One of the point is A. At A, BM over. Other point is B. That also over. Last point is E. Therefore, you also need bending moment at E. Clear or not? You also need bending moment at E. Tell me, clear or not? Fast. You also need bending moment at E. That is the maximum BM in that local region. Why? No confusion? Clear. Okay. Now, how to get it? It is equal to plus M dash X. Substitute X equal to how much? It is the bending moment here is from here to here. Plus M dash X. Substitute X equal to how much? You know the answer there. X equal to, X should be from the point C. Substitute X equal to how much? Substitute X equal to, already see the diagram there, 3.8043 meter, and then minus 2200 into this distance, 2.4043, lastly plus 250. Tell the answer. This is the last BM I want in KN meter. I am sure it will come negative. Today it came negative. That means here sagging, here hogging. In the next question, that also will come positive. Then advantage for you. What? Contraflexure point is not there. That will come in the next example or last example. That will happen when the columns are quite nearby. When the columns are quite far off, this will sag, middle portion will hog. Bottom steel, top steel. But if the columns are quite nearby, full will sag. So entire length, only bottom steel, it will come in the next example. Answer. Plus, minus 1206.91. Minus 1206.91 kilonewton meter. Okay. Now, all the bending moments are over. Now, you go for bending moment diagram. But write a note. Before going to bending moment diagram, you write the variation. Why waste of time? From C to A, UVL, A to B, again UVL, B to D, again UVL. So everywhere between, see, when you write the variation, should not write E. Remember, C to A to B, B to D. I have seen so many YouTube classes. They will tell C to A, parabola, 3rd degree, A to E also parabola, 3rd degree. No, E will not come. It will come in that, what you call, what is the word is there? In that flow it will come. You don't use wrapper E for variation. C to A, right there. C to A, 3rd degree parabola, A to B, 3rd degree parabola, B to D also 3rd degree parabola, but E point is required. At E, parabola pattern will not change. Clear or not? E is not to be referred for variation. Some were told earlier, same person told. Then he agreed. Finally, he told yes, correct. I don't want to tell who and where. Don't bother. Clear. Okay. Now go back and draw the diagram. This is a baseline for bending moment diagram. I will use blue color. Bending moment diagram. All values are kilonewton meter. Sagging positive. Today I am drawing sagging positive, but later in E-tab and SAFE and RCC class, I will not draw sagging positive. I will draw BMD on what side? Tell me if you remember. In the practical knowledge class, I will draw BMD on what? Not sagging. Calculation is sagging positive only. But finally, drawing on tension side. That I will tell in the respective class, or even in this course, when the class reaches around 200, I will tell special concept. How to draw BMD on tension side. Those who are general public, wait till that time. Okay, start. Now, at A, 2 bending moments. One of them, 785.4. One of them, I will use black color. 785.4 and 535.4. Okay. 785 and 5. Okay. Here. One of them, 1198. Little jasti. Okay. It is 1198.8. One more value is 600. ಇದು 600 ಅಂದರೆ ಆಯ್ತು ಇಲ್ಲಿದೆ ಎಷ್ಟದು ಅದರ್ ಒನ್ ಈಸ್ 898.8 ಹಿಯರ್ ಒನ್ ಆಫ್ ದ ವ್ಯಾಲ್ಯೂ ಈಸ್ 785.4 ನೋಡಿ 785.4 ಅದರ್ ವ್ಯಾಲ್ಯೂ ಈಸ್ ಹೌ ಮಚ್ 535.4 ಎಲ್ಲಿ ಬರೆಯೋದು ಇಲ್ಲಿ ಬರಿತೀನಿ ಇಲ್ಲಿ ಬರಿತೀನಿ 530 ಅಲ್ಲಿ ಬರೋದಾಗೋದಿಲ್ಲ I will write somewhere later. See that 535.4 is here. I will write later because I do not want overlap. Okay, start. Now, C to A to B. See here. C to A shear force increases. B to D also, shear force decreases. Tell me. C to A, shear force increases. Therefore, C to A, shear force increases. So, slope of the BMD should what? First. Shear force increases. Slope of BMD should first. Shear force increases. Slope of BMD should increase. Increasing slope is possible. And remember, C joined to just to left of A. This way. Here slope equal to how much? Here slope equal to, oh no. See, here slope equal to 0. Tell why, tell me. See, here slope equal to 0. Why, tell me. At the extreme end, it should go tangentially. Tell why. At the extreme end, it should go tangentially. Why? Because, reason. Tell why no slope here. Reason. Why no slope there? Why the tangent should be horizontal there? Shear force is 0. Okay, now, here slope equal to 722 point something. Okay, now, after coming down here from just to right, join to just to left. Nodi, this is the BM just to right, BM just to left. Now, but do one thing. Before joining, you should also mark the BM at E. At E came minus. Oh, it is somewhere. How much? 1206.91. This is 1200. Little bigger. Okay, Sakuri. 1206.91. Now, from here, tell me, as you go from here to here, shear force reduces. So, slope should reduce. And after this point, again shear force increases. Slope should increase. And I will draw as smoothly as possible. Abba, really? And okay, tell me. Here, slope reduces. Finally, tell what is the slope here? Anybody can tell? What is the slope here? Because that is the point where shear force is 0. Tell what is the slope of BMD here? Yes, I am joined 534 only. I am writing 534 now. This is 535.4. Correct? What is wrong? Just to left is 785. Oh, sorry. Okay. Print mistake. Okay. No problem. See, C joined to just to left. Just to left is 535. Okay. Print mistake. Okay. Thank you. Because it will be embarrassing later if I maintain same thing. Okay. Thank you very much. Anyway, it is not a mistake, observation mistake. I put it. This is 535.4. Then increases. Plus here, minus here, plus here. Then just to right, when you go here, see, again, shear force increases. See, shear force decreases. Slope should decrease. And finally here, shear force 0. Okay, 0 plus. Thank you. Yaar kotrodu? Thanks. Sridhar Murthy, thanks a lot. Why? Because I was seeing there wrong reading. But people will comment tomorrow. See, I would have felt very bad later. Everything did correctly. Joining time, I thought this is just to right, just to left. By number mistake. Anyway, thank you. See, print mistake. Now corrected. 0, just to left is 535. Just to right is 785. Corrected. Then there, just to left is, thank you. Perfectly correct. Thanks a lot. Okay. Now, BMD over. Now, see, in the RCC class, I will tell something. Not now. See now. This is 1206.91. I will tell more in the RCC class, not today. From here to here, sagging, you need bottom steel. Here to here, sagging, you need bottom steel. Between these 2 points, hogging, you need top steel. Of course, the steel will be later extended up to here. That is special RCC. You don't stop here, extend. This also you have to extend by at least development length. That all I tell in RCC. This is the reinforcement required. Oh. Now, therefore, to get a complete idea, now, right, draw BMD. Yes, BMD is drawn. Still not over. Once you draw the BMD, up you write here. Okay, with me. BMD is drawn. Okay. Everything correct now? I don't want any mistake. Okay, okay. Those who know me, those go through my every class. If there is any error in value writing, they will understand. They will tell. Okay, he knows it. He told correctly. Wrong reading. Not a big issue. I will correct. Only people who their purpose is only commenting. Commenting only. When this much effort is put, there are people who will try to find out mistake. If no technical mistake, they will try to find grammar mistake. Or very easily they can find spelling mistake. I don't have that high influence in spelling. I don't bother. See, finding mistake, like meal is good. First find, if you go to a function, they try to find mistake in the meals. If meal is perfect, they will tell, when I went, he did not welcome me. Or some dust was there. People who appreciate good things, they will not comment. Okay. Now, right here, BMD is drawn. Drawn. Now, observe BMD. Tell me. And tell me, are there points of contraflexion? First. Question, you are right. Are there points of contraflexures? If yes, how many are there? If yes, how many are there? If point of contraflexures are there, if yes, how many are there? Bega. How many are there? If point of contraflexure is there, how many are there? No, yes. Answer is yes. There are points of contraflexure. How many are there? Tell me. How many points of contraflexure are there? No. How many points? There are 2 points of contraflexure. Both of them are between which points? Tell me. Both. See, in the next example, point of contraflexure is not coming. By the time you reach here, class is over. Today little delay because of the power problem. Tell me. Both are between A and B. So go back. But instead of going back, don't go back and try to find it, locate it by our usual way. Here, equation is there. See now. Now, there are 2 points of contraflexure between A and B. At both those points, tell me, bending moment equal how much? At one of the point is here, other point is here. At both the points, bending moment equal how much? At both the points, bending moment equal to ಆಗೋಯ್ತು. At both the points, bending moment equal to ಇಷ್ಟೊತ್ತು ಬೇಕಾ? Bending moment equal to 0. Now what to do? Therefore, find at what value of x, for what? Find for what value of what? For what value of x bending moment equal to 0. So do one thing. We know that at x from which point? Tell me. At x from which point? At x from which point? At x from which point? First. At x from C, bending moment anywhere between A and B equal to, tell the answer. If I take x from here, it can be here or it can be here. Anywhere between A and B. At x from here, tell the bending moment. Bending moment equal to what? Plus m dash x. Tell yes or no. Plus m dash x. See, anywhere you want bending moment here. See, plus m dash x minus 2200 into, tell what? If I take x from here, see, anywhere, we don't know, somewhere x, then here, plus m dash x minus 2200 into, how much? First, tell the bending moment here. This is your x minus 2200 into 1.4. Ayoyo. How? I want bending moment here at x from here. I don't know where. Anywhere after A but before B. Bending moment is, this bending moment is m dash x. X equal to x only. Minus 2200 into how 1.4? How 1.4? Tell me. Yes. Into x minus 1.4. See, moment of this UVL for a length of x plus, that is here, minus 2200 into this distance is x minus 1.4, then plus 250. Tell me, fully clear or not? First, fully clear or not? Equation for BM anywhere between A and B at x from C. Tell me, fully clear or not? First, is it fully clear or not? Clear. Now, equate this to what? Equate this to what? Tell me. Equate this to what? But we want point of contraflexion. At the point of contraflexion, BM equals 0. Equate this expression to BM to what? To 0. 0. Therefore, I will write here. Therefore, 267.96875 times what? Times x square plus 3.7109375 into x cube minus 2200 times x. Then tell me answer. Minus 2200 into minus 1.4 plus 250. Answer. Constant. Minus 2200 into minus 1.4 plus 250. Answer. First, minus 2200 into 1.4, then plus 250. Answer. It was ಬೇಕಾ? ಆನ್ಸರ್ ಏನು ಮಾಡಿದ್ರಿ ನೀವು? ಏನೇನೋ ಬರ್ತಾ ಇದೆಯಲ್ಲ ಆನ್ಸರ್. 2200 into 1.4 positive plus 250 correct equal to 3300 plus 3300 equal to 0. You have to solve a cubic equation. Cubic equation. Remember, when there is a cubic equation, it will give you 3 value of x. Tell me. Now how you solve is not my problem. So many calculator, you can use it directly to solve or solve by trial and error procedure. Whatever you do, tell me answer. X, solving the cubic equation, x equal to, someone told there, I will write it to 5 point, okay, he told 5 point, illa tappagide, nodi, first value I want 2 point positive plus 2.001 comma ಇನ್ನೊಂದು plus 5.569 and ಇನ್ನೊಂದು minus ಎಷ್ಟದು 79.781. I do not know. Someone told, I am believing. Correct now? Tell the answer. I will complete another 5 minutes. Someone told, I believed. Okay. Someone has to confirm. All do one thing. I will continue the question with these values. If tomorrow somebody comments that value is wrong, I will tell why you came to my class. Why you came to my class? For this type of comment I am not open. Someone told, I wrote. Okay. 2.001, 5.568 and minus 7. Remember now. Now, see, 3 values are there. Tell me, how many points are actually there? Tell me. There are only what? There are only 2 points of contraflexures between A and B. Yes or no? There are only 2 points are there. Therefore, for both the point, X should be, see, the point should be after A but before B. So X has to be more than 1.4 meter and less than how much? Measurement from here. That X value should be more than 1.4 but less than how much? It should be more than 1.4 but less than, first. It should be more than 1.4 but less than 6.4 meter. Okay, tell me. And with this range, in this range, therefore, applicable values of X are, tell me, yes, plus 2.001 meter and what? Plus 5.569 meter. Correct. That minus 79.781 is non-applicable. Tell yes or no. That number is non-applicable. So between these 2 points, 2 points are there. You got 2 applicable value. Tell me, suppose 3 value, all the 3 are applicable. What to do? Tell me. By chance you get 2.001, 5.569 and 6.148. Tell me. If 3 applicable comes, what to do? If all the 3 comes applicable, what to do? If all the 3 comes applicable, what to do? First, see, there are 2 applicable values. It will not come. My responsibility. I told sometime, I tell with high angry mood. No beam has got courage to give 3 applicable values when only 2 applicable values are there. Therefore, in my class, it can never happen. Not in my class. In anybody's class, if subject is taught correctly with the correct concept, it can never happen. My guarantee. Therefore, and remember, these 2 are the applicable and note both these X values are from where? Tell me. From where? Last chance of making mistake. Both these X values are from where? Both these X values are from where? From C. Therefore, now go back and mark. I will mark here. First value from here to here is one of the X value This x value is how much? 2.001 meter. Other value is here. See, other value is here. From here, I have to sit down here. 5 point first. Fully clear or not? See, this much effort, it should be worth, it should be clear for you. Full clear? Clear. Okay. Now do one thing. In RCC, I want this distance and this distance. Tell why? Because I want where the bending nature will change after this column, after this column. Therefore, tell me, in the RCC class, how much I will write here? This is 2.001. This is 1.4. Tell me, in the RCC class, how much I will write there? Fast. Agoitu. 0.601 meter. I will write here 0.601 meter and tell me what I will write here. From here to here is 5.569. From here to here is 6.4. Tell me RCC class, how much I will write here? That one. 0.831 meter. Over. This is rounded because we calculated. Formula gave you from here only. Now, with this one, SFD&BMD for a combined footing beam or slab type practical important, 2 downward point load and with the couples upward load, not UDL. UDL is very simple. It won't come. It will not come practically. Why should you waste time when practically it is not coming? I told this class is for practical knowledge. So this is SFD&BMD. Furthermore about this one, we will discuss in RCC class and also ETAP class. When I go to design parameters, shear reinforcement requirement, where to give, where to curtail the bars, that all comes in RCC. But there, strength of materials point of view, SFD&BMD, at that time, I will do one thing. Why should I solve? I will set the class so that at the end of the class, I will come to this diagram. Then I will tell, next class, before next class, you complete SFD and BMD and send it neatly to me in the WhatsApp group. I will check it. If yes, I will proceed further with the design. If somebody asks there, sir, not clear, I will tell, not clear for you, for me also not clear. I will tell, I am weak in structures. I will tell that way. Strength of materials, SFD&BMD, I am very weak. Sir, you are putting so many classes there, that is for UDL, etc. This I am very weak. What to do? If they are serious, now, practical point of view is the question. Completely clear with no doubt. Fast, last comment. Practical point of view is everything completely clear? Yes. If yes, we will continue in the next class. So one more class required where these 2 points will come closer. So BMD will come, see this way, it will come this way. It will not come below. Then no sagging or no hogging, only sagging, only bottom steel. Further application either in RCC or ETAP shape class. Okay. Already 9:15 now. Thank you. Next class, I will conclude this one. Immediate next class will be bending stress and shear stress, the most #1 rank in structural engineering. Okay. Thank you. ಇಲ್ಲ ಇದೇನು ಎಂತ ನನ್ನ ಮಾತು ಕೇಳ್ತಾ ಇದೆಯಾ ಎಂತ ದಬಾಯಿಸಿ ಮಾತಾಡೋದನ್ನ ಒಂದು ನಿಮಿಷ ಇಲ್ಲಿ ರೆಕಾರ್ಡ್ ಆಗ್ತದೆ ನಾನು ಮಾತಾಡಿದೆ